either not flexible enough to do what you want. So, for example, when I was working in the market, we had this one thing with Pinterest where they were using an open source library for figuring out validated image URLs. And we had a HTML spec'd URL that Pinterest considered to be invalid because it had like 2 HTTPs in it. And you can actually do that. But because they were using a library that didn't consider this to be a correct spec, and the open source project owner wouldn't accept our pull request to fix it, it was just sort of like a, well, okay, this is wrong, and clearly we're not going to use that for our purposes because we want to be the spec. Also, everybody makes mistakes, and then they live in production forever. And yeah, don't be afraid to say something's wrong. Yes?
Why did they not accept their pull requests?
I think it's largely that maybe they weren't actually maintaining the code anymore, or maybe they just didn't want to be bothered by us.
Okay.
I don't know. I've recently heard that the Git open source, or like the Git repo and everything, would not accept Facebook's pull requests, and so now they're switching to Mercurial, because Mercurial would. I don't know. Facebook also does some weird stuff. So the other thing is, the stuff that you're learning in school is not going to be the stuff that you're doing in the real world. How many of you guys have written like Go for school, or Swift for school, or CoffeeScript for school? The other thing is, have you used Guava before? So Guava is a sort of like a functional overlay on top of Java, and it's not the Java you're used to. And we actually use it in a lot of our code. So you might think that you know Java, and you might feel like you're really comfortable with a lot of libraries, and then you see production code, and you're just like, what is that doing? That's pretty common. And so the implementation doesn't matter. You can usually figure out like, oh, this is probably going to be approximately what this is in this other library, and the more languages that you know, the more consistency you find between them, so that you can hop into a new language easier, and then it's just syntax. You'll figure it out. You're all smart. So next is code reviews. Who's done code reviews? How was the experience? Did you do them for like an internship or school or what?
Internship.
How'd they go?
It's terrible. Terrible. It's terrible.
Code reviews is actually one of the main reasons why I chose to work at Square, because the idea of having someone really smart reading my code and telling me exactly where I'm doing things wrong and exactly how to fix it is an awesome way to learn. And then you also get to read other people's code and you see like how this person with so much more experience to you and you look up to also makes really dumb mistakes sometimes, but also like how they're doing it right. So code review is just like when someone else reads your code and approves it before you merge to master. So the advice that I always give everyone that I talk to when they're asking like, why did you choose what company you went to, or what should I look for when I'm joining a company? Code reviews. They should do code reviews. If there's not code reviews, it doesn't matter how brilliant the engineers are, it's going to turn into a complete and total mess, because we keep each other honest. I know there's many times when I've been working and just like, oh, I'm feeling kind of lazy right now. I'm just going to stick this in here. I know it's not pretty. I'll fix it later. Chances are you won't fix it later. And the other thing is, when someone else does a code review, they're going to see that and be like, WTF, what are you doing? And then you fix it. And then they help you be a better engineer. You should be continuing to learn and grow outside of school. I would hope that you will be a 10 times better engineer after the first year that you're working in a company than you are now. I'm not saying that you guys are bad right now, it's just that it's that 10,000 hours thing. And when you're working full-time, 40 hours a week or whatever it is, you get a lot of hours in. The other thing is code reviews help you figure out like what else is going on in the system, so that like my team is now 7 engineers, and so it's a little bit hard to keep in your mind why and what everyone else is working on. But when you see all the code reviews popping up, then you know, oh, this person's working on this, I should ask this person if this happens, and so it gives you better context when you're working in a larger team. So how do you get the most out of code reviews? I love you. You're all amazing little snowflakes. If you're in a room where you're the smartest person, leave. And you should always, especially when you're working at your first company, choose a company where the people are going to be a lot smarter than you, because that's how you learn. Other thing is, and we talked about this briefly before, don't submit code review or pull requests with massive changes. No one wants to read it. It's going to sit there and rot in people's like inboxes for months because no one wants to look at it. And then the other thing is, you're going to be kind of screwing yourself over because all those massive changes in a moving and working and progressing code base, you're going to have to like pull master, rebase, pull master, rebase, pull master, rebase. And you're going to end up spending like 10 times more time just dealing with merge conflicts. And the other thing is, the more you review other people's code and help unblock them, the better of an engineer you'll become because you're reading a bunch of code. And then they'll also spend more time and review your code. So it's a give and receive type thing. So next is Git. Git's awesome. Software engineering in teams does require source code. I remember when I was working on one of my first school projects, we were like, oh, let's just use Dropbox. It'll totally work. It didn't work. So Git is a magical, wonderful thing that helps you figure out what all the changes are going through your code, and it's useful. I love Git blame. It's a great tool. It's great for figuring out who the bug and who asks questions. If you're having an off day and you're just like, who wrote this, why, then you can get a little bit of satisfaction being like, oh, it's that person. And then that person happened to have left the company like 6 months ago. You're just like, it just becomes an inside joke of every bit of bad code is that person's, and it's fun. And then you can also revert things. So you can like make a bunch of changes, go in a weird direction, and then just make the changes go away. You don't have to manually play around with deleting and commenting out lines. It can just be done for you. Like I said, we have computers to use them. Yes?
Does it ever happen where you like merge something and it seems like there's no conflicts, but then later you realize it merged incorrectly?
So we use Atlassian's Stash, and one of the things that it does is it basically keeps everything really up to date. And I assume that if you tried to push to master and there were conflicts, you would probably then have to like force push, which we've disabled because force pushing to master only results in sadness. But it lets you know if there are merge conflicts. And unless you guys both hit the button at the exact same millisecond, hopefully it's not possible.
Well, not just conflicts, but sometimes what happens is that it merges fine, like textually, but it's just the meaning turns out to be wrong because.
Oh, yeah.
Does that happen or no? A lot.
So that's where the tests are going to save you.
Okay.
If you have a weird conflict and someone kind of messes up what the logic is, your tests should be protecting against that, or if like sometimes it doesn't compile after you've changed things around. We also have a automatic build system where it runs all the tests, and the tests have to be green before you can merge. So it just like little checks in the system to make sure you're not doing something dumb. So a lesson about code reviews: commits should be small and atomic. You should have like small commits that very succinctly say what that thing is doing. And sometimes this is hard to do in practice because you'll be working on something and then you'll forget. Git rebase -interactive is also your friend. It's great. So The other thing is commit messages help you figure out when things, or where things probably broke, and can help you identify basic things like that. So, once again, this is probably hard to read, but let's say that like something's broken, it was just pushed to master, and then all of a sudden support tickets are coming in, and you're looking through the commits and you just see PR style changes, PR fixes. That's useful. Or you see, make clear limit of flag. Keeping even a few million user tokens in memory shouldn't be ... Skip graphic verification, no users already migrated. It's like, oh, something probably happened there. And then you can revert the commit, and then you aren't spending 20 hours trying to figure out all these changes that probably led to this one bug. So, the short of it, be kind to your coworkers. Bugs happen. Don't be afraid of taking down 27 out of 30 servers or whatever it is. It's going to happen. And then think about you in 6 months from now who will open that file, run git blame, and realize the horrible, horrible code was your fault. Questions? Alright, okay. So when other people were working in that shared code base, it broke. So in this situation, whose fault is it? Is it the second person who modified the shared code and didn't know that what they were doing was breaking the code? Or is it my fault for not writing the tests? It's mine. I should have written a test that covered that feature. I should have done something to make it clear that this is an important feature and you should not break it. So it's my fault, and then I have to deal with a long stream of emails and please fix this code, and me not wanting to go download that code and actually make it working on my computer, and I just kind of circled around. So what do tests provide? They provide clarity as to what you're building in the first place. One of the things that we'll do when we're working on a feature is we will have just a long list of all these test cases. So we're doing data processing, for example, and we know that these expected results need to happen. You can write those tests to begin with, and then you can just run those tests as you're writing your code and see what's passing. Tests are also more documentation than any documentation that you actually write is going to be. And then tests also give you a clear path for refactoring. So if there's a huge amount of changes that you want to make when you decide this architecture is terrible and we should fix it, your tests give you sanity that it all works in the end. So on a daily basis, I write unit tests and integration tests. Do people know what these things are? Have you ever been assigned to write them for a class?
No. Thankfully.
Not thankfully. However, I'll get into a story about what UNC calls testing.
I mean, I've actually been assigned to write unit tests for a class.
No, integration test.
Like,
162.
No, like 61 VL. They made us write unit tests, like JUnit stuff.
JUnit, nice.
Yeah.
So unit tests are like these little basic things of, does it do what I want to do? In the example of, we have this data processing thing and we know what we want to get at the end. We're testing just, does this work? It's great for prototyping features. It's actually a lot faster to write all these tests and then do a little command line thing that says, like, go run, or go test, and it's just like done. And it tells you what's passing, what's failing, instead of you going around clicking or mocking out data or doing all these random little things that take your time. They're fast to write, and they only look at a small atomic piece of the code. So if you are writing code that has clear functions that do specified things instead of having like these monolithic functions that do everything at once, you can't really test those monolithic functions because so many things are probably depending on something else that you can write a test for it, but you have no idea where it's breaking. And so you get far less insight into how to fix the problem. And they also help define expected behavior. So they're, say you want to, you put in an input, and you want this output. Okay? Well, a lot of times you can process the code in your head. You can read it line by line and get a good idea of what's happening, but it's really good to have examples, and tests also give you that. Nice, spent too long on that slide. Okay. So a story from UNC is that in a data structures class there, you have to write a double-ended queue. And the assignment actually has you test your double-ended queue by doing an Excel spreadsheet and like making graphs and like writing paragraphs about how you'll test it. It's not testing. If you do this, people are going to look at you really weird in the real world. So, anyway, integration tests are more of like, does this thing talk to this other thing? It's when you're going to be like mocking out HTTP requests, or you're going to be mocking out like expected data from something else, and so you're kind of just like testing if your code plays nicely with others. And once again, it helps define like, is this thing doing what's supposed to? Is this thing going to talk to this other thing in the correct way? And it helps define like the right ways of interacting with each other. Another story from UNC is in our networking systems and protocols class. You have to write a server and a client. And the way that we tested our server and a client is we were in the computer science building at 2 in the morning, sitting in a circle, being like, hey, here's my host, here's the port number, can you run your thing and see if you get a response? And we're just like manually on the command line, testing each other's code. It's not really very efficient. There's an easier way to do this, and this is why we have computers. All right, next thing that they don't teach you about in school is documentation. Documentation is pretty hard to maintain, and it's usually outdated and non-existent blurbs about what a piece of code did the first time it was written. Because the first time you're like, oh, this is going to be great, it's going to be clean, it's going to be awesome. And then your road path changes, and then the thing that you wrote the first time does anything like the documentation and little, like, nice little comments that you have when you start it out. So documentation is really your source code and your tests. So documentation is, something you hear about in class. Your teachers may even say you have to like use, JDoc or whatever it is for Java or JavaDoc, and you have to have comments about all public methods and all this other stuff. Chances are it's not going to happen in the real world. And even if you are a perfect engineer and everything you write is always like perfectly documented, the engineer that comes behind you and changes what your code does isn't going to do that. And so it's just not going to stay up to date. You do see good documentation in some places. So if you're going to be open sourcing something, Squared is a lot of open source. And one of the processes that happens whenever we open source a product, or not product, like a service or library or anything, is the engineer will probably spend a week or two just cleaning up their code, documenting it, and making it easy for someone else in the world to use. That's not production code. So your source code and your tests are your best form of documentation. This is why in classes your professors are probably going to give you like a series of code that is just written out on a piece of paper, and they want you to figure out what it does. And when I was in school, I was just like, well, the computer's going to do this. Why do I have to execute these things in my head? Well, it's kind of hard to always execute these things or get your computer to execute everything for you. And you have to be able to understand what's going on when you read and write code. So here's an example of some of our Git blame history for one of our services. It's a little hard to read, but you'll see that there are commit dates from 2011, 2012, 2013, and 2014. This code is line by line Git blame, and as you can probably tell or probably deduce from this mass of commits, the code is nothing like it was before. Any documentation that you had in the beginning is probably not going to correspond to what it is now, and this is pretty common for production level code. So the next thing is, it's APIs all the way down. Everything what we do is an abstraction upon another layer. So an API is an application programming interface. But when I was in school, I always wanted to know how everything worked. So I would like look at the source code for how Java did whatever random thing, and I wanted to know like what this piece did and what this piece did, and then I'd kind of move back up and try and understand like how all these things are working together. But there gets to a point where that's impossible. You have to just accept that you're going to be working on a silo of a very large code base, and you just have to accept that the other things are doing what they're supposed to, and understand your little piece of it. You have to figure out how to jump around in a lot of code, and then just accept that things are working the way it is. There are black boxes, and that a lot of the code is a black box. You might have libraries that are compiled, you have no idea what's going on, and you just have to sort of get your head around the fact that you're just not going to know how the system works. Does that make sense? And also ask questions.
What do you mean by C-Git?
Oh. So Git, I have a section on Git in here, and you can use git blame, so that thing that I showed to figure out who to ask, which is also how I got tagged for the code that was being broken. Just like, your name is all through this code, clearly it's your fault. The other thing is, most of the code reviews that we do at Square, a lot of times people will just comment on, can you name this thing a different name, or can you name this function something else, because this doesn't quite make sense, or this isn't conveying to me what you think is conveying to you. There was at one point in our code where there was like 7 different things that all mapped to config. And as we were writing our code, we didn't know what config got mapped to what thing, and then we did a massive refactor and got rid of that, and it's better, but naming is hard. And so when you're reading through code, don't always take it for granted that whatever you're seeing is right. In open source, a lot of times it's wrong. One of the things that contributes to the not invented here principle of like companies writing